Okay, so today we talk a lot of vocab and a lot of, foundation on what a radian is, what a degree is, how to convert, how to find coterminals, how to find arc length. Like all that stuff is in today's stuff. So we're gonna plow through the notes today, and then I'm not here Monday. You're gonna get to work on the homework in class. Okay, so you kind of get a homework, you get a homework-free weekend. You'll get to work on this assignment on Monday. Okay, so the parts of an angle, some vocab terminology here. The parts of an angle are on your next slide, okay? The initial side is where your angle starts. The terminal side is where it ends, and where they meet is your vertex. So, parts of an angle, okay? Some vocab terms here. The initial side is always where your angle starts. The terminal side is always where it ends. We remember, hopefully, from any kind of geometry, that where these two meet is called the vertex. Now, the direction of the angle will sometimes be shown to you with an arrow. So that's telling you the direction of the angle. If there is no arrow, it means that that angle is going counterclockwise. Okay, so just like this one is. And if I put that angle on the x-axis, and then I go, so if this is my initial side and then the terminal side is anywhere else, this is called being in standard position. So standard position means that my angle starts, or the initial side of my angle is on the x-axis pointed towards the right. All right, so positive and negative angles. Positive angles go in a counterclockwise rotation. And negative angles go in a clockwise rotation. And again, if the arrow's there, you follow the direction. If the arrow's not there, we assume the angle is positive and would be going in a counterclockwise rotation. All right, here's the confusing part of radians for some people and degrees. The radian is just another unit of measurement. So a radian is like the length of the arc, okay? And the length of the arc is like the outer ring, right? What do we call the measurement of the outer ring of a full circle? Circumference. So the radian is like if it was a circumference with a radius of 1. How do I find circumference? What's the formula? 2 pi r. What if r is 1? Now what's the length of that circle? Or what's the full circumference of that circle? 2 pi. So when we talk about a unit measurement, when we take something from degrees to radians, we're talking about it in terms of how much of my circle, if my full circle is 2 pi. Okay? So when you look at it this way, because I think it's a little bit easier, the entire circle would have a length of 2 pi or a circumference of 2 pi. And that means if I convert this I use that for my radian degree, that if an angle starts in standard position, okay, and goes all the way around, then the measure of that angle in radians is 2 pi. It's the full circle. If I go halfway, what would be half of 2 pi? Pi. Halfway around your circle is pi. And then if I cut it into fourths, if I cut that half into half, if I only go a fourth of my big circle, what would that be? Pi over 2. Pi over 2. A quarter of 2 pi or a half of pi, right? Okay. And if I go 1.5 quarters around my circle, so if I start here and I go 1.5 ways around, or if I go 3/4 of the way around, then it is at 3 pi over 2. So the very first thing you have to understand is just these quadrant angles. So if I were to draw it on a blank grid, I would start at the right at 0. All the way around would be 2 pi. Halfway would be pi. At the top would be pi over 2. And at the bottom would be 3 pi over 2. You with me so far? Next week, we're going to learn how to fill in all the special angles in between. But for now, we need to understand the quadrant angles, okay? So 0 or all the way around 2 pi, 1/2 pi at the top, 1 pi on the left, 1 1/2 pi on the bottom. Now, this is in terms of pi. If instead I don't keep pi in my answer, I would multiply it out. So let's say I would just say this is 0. What would be pi's value if I didn't use the symbol of pi? 3.14. What if I doubled that? 6.28. So you're going to see radians written in two ways. Most commonly in terms of pi. Like it would say 3 pi over 4. And that would be in terms of pi. But less common, but still existed, is something like 2.5 radians, where pi is not in your answer. So if I asked you to find where 2.5 radians was, this is the trick I use. Feel free to do the same thing, or if you know something else, use it. What I do is I take a circle, and I immediately say, if this is 0, then a little bit less than half would be 3, because this is 3.14, right? I know exactly half is 3.14. So a little bit less than that was 3. That means that from 0 to 3, there should be radian 1 and radian 2. So I take this and I chunk it into 3 sections, approximation. So this would be about 1 radian. This would be about 2 radians. So I mark 3, and then I take that curve and I split it into 3 parts. You with me so far? And then if I draw a diameter through my center to the other side, extending 1, 2, and 3, I would get 4, 5, and 6. So if it asks me where approximately is 2.5 radians, it's a halfway between 2 and 3. That's really not halfway, but you get the point. It's an approximation, okay? So you'll see a homework question that says, here's an angle, approximate how many radians. It doesn't want it in terms of pi. So if it had said, here's an angle, let me actually draw the angle. It said that, and it said approximately how many radians it is, then if this was a quiz or a test, I would literally draw my circle, make this the 0, make this the 3.14, which makes this 3 to 6, split it, 2 and 1, draw it through, this would be 5, and I would know that initial angle was approximately 4 radians. So again, when you don't see pi, it means it already multiplied out the pi. To me, this is the most confusing part of this whole section. And it's very small. Like you might get one question on the homework on it, okay? But it's important to understand that when you see something that says 2.5 radians, that doesn't mean 2.5 pi. That means 2.5. That means pi was already multiplied in, okay?
So then there's 6 radians in a circle?
There's, no, 6.28.
Okay.
In a full circle. Yeah. Does that make sense? Okay. Halfway, 3.14. Yep. All right. So now we're going to talk about how we would draw these angles and then also state the quadrant which it lies in. So 2 of these are quadrant angles. These are ones we need to be good at and fast at. And then we're going to talk about the last one. Where did we say 3 pi over 2 would be? At the bottom, yes? We said this would be a half pi. This would be pi. So 3.5, or 1.5, which is 3 halves, would be at the bottom. Now, if you were to describe this in quadrant form, is that in a quadrant? No. What do we say? Where is it? It's on the y-axis. Good. So if it's not on a quadrant and it's on an axis, we name the axis it's on. Go to B. Where is 2 pi? On the right, all the way around, one full circle is 2 pi. Good, x-axis. So you should be able to do from memory 0, pi over 2, pi, 3 pi over 2, 2 pi, because those are your quadrants. Again, next week I'm going to teach you how to fill in the stuff in between, and we'd get that, so we'd get to see faster. But for now, the other option is I take 7 pi over 4 and I make it a mixed number. What is 7 over 4? 1 3/4 pi. Where did we say 1 pi was? So this is 0. This is 1 pi, right? This is 1 pi. This is 2 pi. This is 1 1/2 pi. At the top it's pi over 2. So 1/2 pi. So 1 3/4, does that lie between 0 and a half? Between a half and 1? Between 1 and 1.5? Or between 1.5 and 2? Where would 1 3/4 go? I'll say it again. Between 0 and a half. Does 1 3/4 go between 0 and a half? No. Does it go between a half and 1? No. Does it go between 1 and 1.5? No. Does it go between 1.5 and 2? Yes. So I know this goes in which quadrant? Quadrant 4. So if you don't know where the angle goes, convert it to a mixed number, and then it's going to literally be in one of those 4 sections. It's either going to be between 0 and a half, 1/2 and 1, 1 and 1.5, or 1 and 1/2 and 2. And then you would know what quadrant to put it in. We good so far? Okay, now we're going to talk about coterminal angles. Coterminal angles that are in the standard position. Standard position means it starts at the x-axis on the right-hand side where 0 is. That have the same terminal side. So these mean that they start at the same spot. So let's say I'm just talking about pi. Pi is where? On the halfway mark, which is on the left, right? So pi would be that angle, yes? Okay. But also 3 pi. Well, 3 pi means you're going, this would be 1 pi, this would be 2 pi, this, back around again, would be 3 pi. So pi and 3 pi are going to be called coterminal angles because they both start at the same spot and they end at the same spot. The way you find a coterminal angle in radians is we add or subtract 2 pi because we want to go one full revolution around your circle. So this means every odd whole number multiple of pi ends here. Pi, 3 pi, 5 pi, 7 pi, 9 pi, 131 pi would go to the left side of my graph, okay? And it means every even whole number multiple goes on the right-hand side. So 0, 2 pi, 4 pi, 6 pi, 222 pi are all going to be on the right-hand side. Odd left, even right, okay? But it also means if I have something like pi over 4, that I can add 2 pi to that. So pi over 4 plus 2 pi. Change it so it has a like denominator. So there's a lot of like quick fraction, least common denominators in this chapter. This would be 8 pi over 4, and that becomes 9 pi over 4. And that would be the same spot because it would be 2 and 1/4 pi. So those are coterminal because they start in the same spot and they end in the same spot. The number of revolutions are just different. So to find them, we're going to add and subtract 2 pi. So example 2 says, find 2 positive and negative angles that are coterminal to the given angle. So we're just going to find one of each. One positive, one negative. One negative. Okay. So if I'm starting negative and I want to get to a positive one, what are you going to do? Add or subtract? Add. I'm going to add 2 pi. So this becomes 8 pi over 4, and I get 5 pi over 4. Is that a positive angle? Yeah. Yes. So this is the positive coterminal angle. Sometimes your initial angle is so far negative that you have to do it twice to get positive. But if it's asking for a positive, it has to be positive. It's not just adding. Sometimes you got to add more than once, okay? Or you add 4 pi instead of 2 pi, that kind of thing. Okay, if I start with negative 3.3 pi over 4 and I want to get a negative coterminal angle, what are you going to do? Subtract 2 pi, which is 8 pi over 4. And I get negative 11 pi over 4. So if I had graphed these angles, all 3 of them would start and stop at the same location. If I wanted 2 positive coterminal angles, what are you going to do? Add 2 pi, good, to the one we found, right? So if this was my first coterminal positive angle, if I wanted another one, I'm going to add 2 pi again. All right, you do B. So find a positive and a negative coterminal angle to 5 pi over 6. All right, what's your positive coterminal angle? 17 pi over 6. Good. What's your negative coterminal angle? Good. Questions so far? Okay, so now we're talking about first angles in degrees, and then we're going to talk about how it relates to radians, okay? So the degrees part I think is easier, actually, okay? The degrees, because you guys know a circle, right? I go from 0, one line would be 180, all the way around is 360 degrees. So we would double back at 360 degrees. Halfway between 0 and 180 at the top would be what degree measurement? 90, right? This is a 90 degree angle, okay? Halfway between 180 and 360 is 270. So the quadrant angles is what we're starting with so far. We're going to learn how to fill in all the things in between. But it is 0 degrees and 0 radians on the right. It is 180 degrees and pi on the left. It is 90 degrees and pi over 2 at the top. It is 270 degrees and 3 pi over 2 at the bottom. And it would be 2 pi, well, let me go in the same order. It would be 360 degrees and 2 pi all the way back around in that same spot. Now the negatives go the other direction, right? So if I start at 0 and I work my way clockwise, then negative 90 is at the bottom, negative 180 is the same spot at positive 180, negative 270 is at the top, negative 360 would be back around where 360 is, okay? So notice a couple things about your negative angles because there's a couple different ways to figure out how to graph them. One is I could learn the direction. So if it said negative 100 degrees, I wanted to graph that, I have two options. One is work my way clockwise in the direction, because that's where it would be negative. I know it's just a little bit past 90, and I'd plot it there, okay? That's one option. The other option is find where that angle would be positive and fold your graph like a hamburger. So where is a positive 100? Well, it'd be a little bit after the 0. It'd be a little bit after 90. This would be a positive 100. And then I fold it top to bottom, and that's where that angle is negative. Honestly, degrees I don't think are too bad, but when we start to get into our negative radians, I would say people struggle a little bit. So when you start to learn where your radians are, I think it's easier to do what I just did. I think instead of learning where negative 5 pi over 6 is, I'm going to learn where 5 pi over 6 is and then fold it like a hamburger. Okay, so now how do we find coterminal if we're in degrees? Well, 2 pi is the equivalent of 1 full circle. What's the 1 full circle in degrees? 360. So instead of adding and subtracting 2 pi, we add and subtract 360 degrees. So the second thing so we did coterminal. Well, we drew original angles. We did coterminal, and then we're going to learn how to convert between radians and degrees. So to get from degrees to radians, you multiply your angle times pi over 180. And to get from radians to degrees, you multiply by 180 over pi. Now, typically radians have pi in them, but they don't have to. So you might see something that says 3 pi over 2, and I know easily that's radians. But I also could see 3.2, and that is radians. The only way you know for sure is the absence of the degree symbol. So an angle in degrees has to have a degree symbol, and an angle in radians does not have a degree symbol, okay? So it doesn't mean it has to have pi. So this would be in degrees, but this would be in radians. Typically, they're not huge numbers because a radian is not usually huge, okay? But it doesn't mean it doesn't have to be. Like 15.2 could go either way. 15.2 without the degree symbol means 15.2 radians. 15.2 with the degree symbol means degrees, okay? All right, this is why you need your calculators. So we're going to learn how to convert from something called degree, minute, second notation to decimal degree. So if we look at the difference between these two notations, okay, it's a little blurry, but this is called degree, minute, second notation. Degree, minute, second, or DMS for short. And this guy is just your regular degree, which we call decimal degree. So without our smart calculators, the long way to do this is exactly what this sounds. A degree measurement, a minute measurement, and a second measurement. So now like if you could picture your circle as a clock, let's say. If I said it was 3 degrees, I would go to 3 degrees. And then if I said it was 1 minute, I'd literally just go 1 little minute. And seconds, you almost don't even see, but it would be close to that spot. If it said 142 degrees, now I'm in my second quadrant, 142 degrees, 5 minutes, I would go travel like it would be 5 minutes on a clock, and then seconds. The good news is you don't have to do this because you can convert it to decimal degree and then graph it like normal, okay? So this part is your degree. That part we will never change. We'll keep it as whatever it is. The second part is your minutes, and if you didn't have what I'm about to show you on your calculator, you would take that and divide it by the number of minutes that are in an hour. How many minutes are in an hour? 60. So I would divide it by 60. And then I would take the third part, which is seconds, and I would divide it by the number of seconds in an hour. How many seconds are in an hour? 3,600. Good. So you would divide it by that, okay? The good news is your calculators have a button that does this for you, okay? So let me switch my... Okay, so we're going to spend a lot of time in this menu. It's above the apps menu. It says angle. So when you hit second, apps, you get this angle menu. And there's where your degree symbol is. There's a single tick mark. And there's... Do you see it? No, we're delayed. Okay. Do you guys see it? So hit second, apps, and look at your angle menu, right? Top 2 things are degree, 1 tick mark, and the 4th thing on the list, we skipped 3 because we'll talk about it later. 4 is arrow DMS. So if I want to go from degree, minute, second notation to decimal degree, then I'm going to go back to the regular menu. I'm going to type in 31 because that's the degree. I'm going to go second, apps, and I'm going to hit 1 to get the degree symbol. Then I'm going to type in 47. I'm going to go back to the degree or the angle menu, and I hit the single tick mark, and I hit enter. And then I hit 12, and I get what you're thinking. Go back to the same menu because it would make sense that it's there, but it's not. I don't know if they forgot about it and had to add it in later. It is actually above your plus symbol, and it is green, which means you have to hit alpha plus, and that's where you get your double tick mark. And then you hit enter, and it's going to convert it into decimal degree. Everybody's with me so far? So question on homework is literally going to say, take this angle that's in degree minute second notation, convert it into decimal degree. Then you could get it in decimal degree, and it's going to ask you to put it back into degree minute second notation. So if I go to the rounded one and I say 31.787, I go back to the menu, second, angle, and the 4th thing in the row is arrow DMS. It's saying take something that's in decimal degree, put it in degree minute seconds, hit enter, and it's in degree minute second notation. Now it's not exactly what we started with. Why? Good, we rounded it, right? So it's not perfect. If it asked you to take, like if I had done it, what I had done before, if I had taken that whole rounded one, I would expect to see it a little bit closer. I mean, not the whole rounded one, the whole stored one. I would go 4. Now it's exactly what I started with. A rounded one's obviously going to be a little bit off. So we need to know how to convert for now because it's literally just going to ask you how to convert, but you also need to know how to convert for future because it's going to build these into word problems and other things when we get to law of sines and cosines. It's going to give it to you in terms of degree minute second notation, and you need to know how to get it into decimal degree. All right, so example 3 says convert the angle from radians to degrees or vice versa. So how do I know if it's in degrees? Has to have a degree symbol, okay? If not, it's radians. So convert from from degrees to radians or radians to degrees. Obviously, I'm going to multiply 30 times pi over 180. But then I want to simplify. I don't want a decimal. So I can cancel out the zeros. I can cross cancel, right? I can cancel top to bottom or cross cancel. And then I can say 3 goes in 18 6 times. So this is pi over 6. And that's how I'll write my answer. You want to keep it exact. All right, so pi over 2 times. Now we're going the other direction. 180 over pi. The pi's are going to cancel, and 2 goes into 180. How many times? 90. Think about it. Where was the pi over 2 on our graph? At the top. Where's the 90? At the top, okay? All right, 160 times pi over 180. I'm going to cross through the zeros again. And what goes into both 16 and 18? 2. This would be 8. This would be 9. And I'd get 8 pi over 9. And then back to radians. 3 pi over 2 times 180 over pi. Pi's cancel. 4 goes into 180. I can start with 2 if you want. 2 and 90. And then 1 and 45. 3 times 45 is 105. No. 45 times 3 is 135. Questions? So let's say, hopefully we're going to get good at the radians, but let's say we had to ask, it asked you to graph one of these and you had no idea where a radian is located. What's an option you could do? I could convert it to degrees and I could graph it based on my degrees. You guys are probably a little bit better at this point anyways of graphing degrees than you are radians. Eventually we're going to get there. Like you're going to be so good at the unit circle, you'll know where these are. But for now, if you were like, I don't know where that is, I could convert it to degrees and then find it. 2 more topics and we're done. The next one is complements and supplements. And this goes back to what we know from like geometry, right? Or before. What's a complement? 2 things that add up to 90 degrees. What's a supplement? 2 things that add up to 180 degrees. So if it gives you an angle and it asks you to find its complement and it's in degrees, we're going to do 90 minus that angle. If it asks you to find the supplement and it's in degrees, we're going to do 180 minus the angle. If it's in radians, the equivalent of 90 is pi over 2, so we do pi over 2 minus the angle. And if it's in radians and it's asked for the supplement, the equivalent to 180 is pi. So we do pi minus the angle. What you don't want to do here is have to convert from radians to degrees, find it, and then have to convert it back. Okay, that's a complete waste of time. So we need to learn these. Complement, 90 minus the angle if it's in degrees, pi over 2 minus the angle if it's in radians, supplement, 180 minus the angle if it's in degrees, pi minus the angle if it's in radians. And note on the bottom it says both the complements and supplements have to be positive angles, which means if it's bigger than 90 degrees, it doesn't have a complement. And if it's bigger than 180 degrees, it doesn't have a supplement. So if it said find the complement to 110 degrees, we would say there's none. If it said find the supplement to 200 degrees, we would say there's none. So you cannot make it negative. You would just say it doesn't exist. All right, so example 4, find, notice it says if possible, find, if possible, the complement and the supplement to each angle. Let's start with B because it's in degrees, a little bit easier, right? So for B, if I want to find the complement, how do I do it? Subtract it from 90. And 82 subtracted from 90 is 8 degrees. And how do I find the supplement? Subtract it from 180. 180 minus 82 is 98 degrees. You guys really got to stop yelling at me this morning. Rowdy bunch. Okay, then from in radians, the complement is subtracted from what? 90. Which in radians would be? Good, pi over 2. Pi over 2 minus 3 pi over 4. Let's say we don't notice that it's smaller. I would change the pi over 2. I'd have to multiply by 2 and multiply by 2. So 2 pi over 4 minus 3 pi over 4. And what happens? What's your answer? Negative pi over 4. Can a complement be negative? No. So there's no complement. If you see it from the beginning that 3/4 would be bigger than 1/2, you could say it and save yourself the trouble. Then supplement, we're going to subtract from pi. Pi minus 3 pi over 4. I make 4 pi over 4. This is a pi. Minus 3 pi over 4. And I get pi over 4. So there is, on that one, there is no complement, and the supplement is pi over 4. If the question is given to you in radians, it has to be answered in radians. If it's given to you in degrees, it has to be answered in degrees. Obviously with the exception of the convert answers. If it wants you to convert, it wants you to actually convert. We still good? Yes? Okay, last topic in this section is arc length. So when you do arc length in geometry, we do, I don't know if you remember, but you do the measure of the arc over 360 times 2 pi r. So you're saying what fraction of my circle's circumference is the arc length? Arc length is literally like the crust on the pie. So just this outer edge, okay? When we do it in trig, we keep it in terms of radians. So all you have to remember is S, which stands for arc length. Don't ask me why. Somebody got drunk and thought that would be funny, I guess. Okay, S stands for arc length, equals R, which is your radius. That one makes sense, times theta. Theta is the value of the angle in radians. So I just switched this around and I remember SOR. Feel free to do the same if that makes sense. Okay, S equals, this is theta. Some good Greek prep for you if you're involved in a fraternity or a sorority. That little value is theta. Okay, we're going to use it a lot in chapter 4. And the R stands for radius. Notice that the theta has to be in radians. So if it's given to you in degrees, the first thing you're going to do is convert it to radians and then plug it into this equation. So example 5, find the length of the arc. Number 1 says R is 3 and theta is 120. Is theta in radians? No, so we got to convert it. How do we convert to radians? Good, multiply by pi over 180. So the zeros again cancel. 2 goes into both those. 3 also goes into both of those. This would be 4 and 6, and then I can go 2 again. So 2 pi over 3 is theta. And then I just plug it in. S equals 2 pi over 3 times R. We're keeping it exact, so you'll just simplify this if you can. If not, you'll multiply it straight out. These 3's cancel. And so the length of this arc is 2 pi. If it gave you a unit, it could be centimeters, inches, or whatever it is, then I would add that on. Go to 2. There's a lot of space there. Go to 2. So what's theta this time? 4 pi over 5. Is it in radians? Yes. 7 is your radius. So S equals 4 pi over 5 times 7. Can't simplify it. Multiply straight across. 7 would be over 1. So in the numerator, I have 28 pi. And in the denominator, 5. This time it gave you a unit. This is centimeters. So the arc length is 28 pi over 5 centimeters. Questions on that one? Okay, and then the last thing is we can give this in any kind of order. So it doesn't always have to be that you're given theta and the radius. Maybe you're given the arc length and theta, or the arc length and the radius. So find the radius of the circle with the given information. The length of the arc, which means pi equals S. And theta is 3 pi over 2. So S equals theta times the radius. S is pi. Is theta in radians? Yeah, so I don't have to convert it. I'm solving for R. How do I isolate that R? Divide by what? So I could divide by 3 pi over 4, which means I'm going to multiply by its reciprocal. I could do it all one step, which is 4 over 3 pi. Or I could have done that in parts. I could have multiplied by 4, then divide by 3, then divide by pi. How you do that is fine. It's up to you. But the pi's cancel, and I end up with, this is gone, R equals 4/3. It didn't give me a unit, okay? It didn't say arc length was pi, inches, or centimeters. Otherwise, I would use that. All right, then B.
Bye-bye.
Bye. S equals theta times the radius. S is what this time? 24 pi. Theta is 4 pi. I don't know R. Is theta in radians? Yes. So I just have to divide by 4 pi. r equals, the pi's cancel, and 24 divided by 4 is 6. Questions on these? So it could also give you the radius and the arc length, and you'd be finding theta. Like it could give it to you any two of those three, okay?